Okay, we're going to go through CAPM graph stacks. What we're doing here is starting with position graphs and going through velocity and acceleration graphs. We don't have any numbers here, we're just drawing the shapes, trying to get a feel for it. So this first one here, the slope of the position graph is positive and constant, which tells me that the velocity value is positive and constant. So this is a CVPM. The velocity graph slope is 0 and constant, so the acceleration is 0 and constant. Again, CVPM. For B, the slope of the position graph is negative and constant, so the velocity is negative and constant. And the slope of that constant velocity graph there, that's 0, so the acceleration is 0. If I go back to check, if I look at the area under this velocity graph, I get positive value, which tells me a positive displacement. Yes, that's what it has. Negative area here, negative displacement, correct. Okay, in C, my position graph slope starts out as 0, and then it gets more and more negative. So by the end of the graph, it's quite negative, and if it's CAPM, it's going to be linear. So that's what my graph looks like. My V graph's slope is negative. The values are negative, but the slope is negative. That's what tells me about acceleration. So to check displacement, the area under the V graph here is negative, and that is negative as well. The area under the A graph tells me delta V. This area is negative, so the velocity decreased, or went from 0 to a negative number, which is what happened. All right, another CAPM one. The slope starts positive and big, so I'm going to start positive and big, and then it ends 0. So that's going to look like that. And the slope of the velocity graph is negative and constant, so my acceleration is negative and constant. So the area under the A graph, which is delta V, is negative. V did indeed go to a lower value. The area under the V graph is positive, so we have a positive x displacement. That's what we have. All right, in E, we have two graphs kind of stitched together here. The first part of the graph is linear, and the second part is a parabola. So this position graph here has a constant slope of 0, so my velocity has a constant value of 0. The velocity is not changing, so the acceleration is 0. So that's CVPM. It's a very boring CVPM too, no velocity. In the second section, the slope starts 0 and then gets more and more positive. That's what my velocity graph does too. Starts at 0 and gets more and more positive linearly. The slope of the velocity graph here is positive, so I have a positive acceleration during this interval. In F, we also have two graphs stitched together. Parabola and linear again. So initially, my x-graph has a slope of 0, so I have a velocity of 0. Then that gets more and more positive. After that, I have a constant positive slope, so I have a constant positive velocity. The slope of this v-graph is positive, so the acceleration is positive during this interval. During this interval, the slope of the v-graph is 0, so there is no acceleration. So we have CAPM first and then CVPM second. So you might see this if you're like running a race. So you accelerate, and then you hit your top speed, and you're cruising at constant v. We have another pair stitched together here. Linear and parabola again. The first section, the slope is constant and positive, so the velocity is constant and positive. The slope of the velocity graph is 0, so the acceleration is 0. The second part of the graph, the slope starts positive and relatively large, and then ends up at 0. So the velocity starts positive and then decreases to 0. The slope of this section of the graph is negative, so the acceleration in this section of the graph is negative. Here we have two parabolas stitched together. In the first section, the velocity starts at 0 and then gets more and more positive. It gets positive and bigger. In the second section, we start with that big positive V, and then it decreases. So this first section, the V graph, has a constant positive slope, so we have a constant positive acceleration. You have a constant negative slope of the v-graph in the second section, so a constant negative acceleration.